Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello once again, everyone. This is Jean-Marie, your teacher. So today, I'm with all of the senior 5 students. I think that you are ready with your calculators and the physics notebook to write down some explanations, right? And you sit comfortably in front of your TV screen, and then you follow the lesson. I wish we could now get at the end of this lesson, all of you be able to explain some of the objectives that we are having throughout this lesson. So the lesson, of course, the lesson is about a complex electrical circuit, as you remember. So we have the competence. At the end of this unit, you should be able to construct and analyze a complex electrical circuit. I think that you have even finished to match with this point that you are saying, okay? So please, students, I want you now to see the objectives. By the end of this lesson, you should be able to perform an experiment using a simple potentiometer circuit. I think that last lesson we had a time to observe how the devices are connected on a potentiometer, right? And in the same way, so we recall again that the way we did into the lesson. And then we can now continue, right? But we are not going to use the materials, but we use the diagram. Do you understand? The same diagram as the one that we were using. But now it is going now to determine the resistance of a cell and then to determine the current by potentiometer, okay? Now, students, this is lesson number 5, which is, of course, to determine the internal resistance of a cell. Check your physics books. The one of senior 5, physics learner book for Rwanda Secondary Schools, S5, 2017, page, check on this, what we are explaining, page number, it is 118 up to 119. And then page 123, you find some more exercises. As you remember, we had the explanation of our last time. We had the explanation about linear potentiometer and the rotary potentiometer. So this one, to add on what we have said, so as you see, this device here, let me tell you, it looks as a device, part of the device that we have from a radio. The one that you use to change the volume, to change the frequencies of your radio, right? So this is what we have here. So, but now, as what we have, normally it is for increasing or changing the magnitude of your volume, the volume of your radio, right? So this is what I can add on to what we have here, but this one, it looks as what you can adjust to change the frequencies, okay? So then let's continue now. Today, we are going now to explain the way this potentiometer works on the principle of changing the resistance of the wire, and the current also is changing, okay? So we explained, so when the resistance, when there is a change of the wire, the wire length, the resistance changes also, right? And this is what we have. Then the current changes. Okay, so this is a point that we can now end this relation having into our explanation. So let's start now with a simple circuit potentiometer. So as you see, we have a diagram. So this diagram, so we have a driving, I think that you are following me, yes? We have a diagram. So this diagram, there is a potentiometer as what we have here. This is the wire. So there is a cell, and this cell is connected now to this one, as you see there. And then there is G. This G means galvanometer. Galvanometer. So this is a galvanometer. So and then here we have down here, there is that resistance that we want to find the current that is passing through that this one. But before this, we are going to find the internal resistance. Internal resistance, here we have electromotive force and internal resistance of this. And this is the potential difference driver, or the voltage that's driving our circuit. Okay, so this cannot change. It doesn't change. So I hope that you are following. I was trying now to give you, or to let you have now this explanation of the diagram. First of all, you have the connection of the terminals of the battery to the wire to the potentiometer, right? And then we have the cell. That is the cell that we want to find the internal resistance. And we have the resistance. This is the resistance that is going to help us to find this internal resistance of a cell. Remember, here we have internal resistance of a cell. So how can we find this one? First of all, if we observe on the the length at a variance point. So students, what is this variance point? So this one. This variance point means where, so this variance point, so this means that where the galvanometer, so yeah, where the galvanometer indicate zero. So it means that zero, that is zero reading. So there is no reading. So it means that the needle deflects backwards, deflects up to zero. So this is the variance point. So at variance point here, so if you have the point AB, in other words, the VAB, so is approximately equal to L. So if we have from here to this point, we have L, right? So then we have, so remember, what is here? It is a switch. So in another word, this is at open switch. When the switch here, the switch S is open, then we have this proportionality, okay? So then we have the constant of proportionality. You remember from the last time we said that is K, then times L. This K is what we called what? Good. The potential gradient. You remember that very good, gradient. So this potential gradient, of course, is the one that you will think to be having when there is a change of that, and then we could find the change of V over change of L, and then here we find the potential gradient, which is, of course, that K. So this is at a variance point when the switch is open. And when the switch is closed, when the switch the switch is closed. What do we find? We find this E proportional to L. Let's say that. No. So even if we are saying here we have L, but of course, let's start by that. So let's call this as L1, or okay, L is 0, and this here we have L is 0. But now here there is L. Here it is L. So we are trying now to match with our diagram, right? So that's why I'm changing that one. If we did not show this diagram, we could now continue with the L that we suppose now to have here. So then this means that E, it is, this one is L, so it is equals to KL. So if we come back to this VAB over E, this will be equal to L0 over L. Good. So we have this from the beginning of this analysis of a simple circuit potentiometer. So from this one, so we can now say that, what can we say? When we consider this circuit, the circuit here, do you see that? So this circuit, when the switch is closed, this one will give the loop. Let's call, this is a loop, let's say that is a loop, this loop. So let's call it as a loop. So this loop, we have, when the switch is closed, then we have E, which is equal to that is electromotive force equals to the current times R plus current times this one. So please, we are trying to apply the Kirchhoff's law that we have defined again into the previous or into the other lesson, whereby we say the sum of the EMF around the loop equals to 0. So and this time now there will be E, which is then minus I, R minus I, R small equals to 0. And this gives what we have defined here, equals to I, then R plus I, then here there is R, okay? So then let's take this point or these things into what we have up there. So we are going to substitute. If we are going to substitute, so what do we find? So here we are going to find this is VA. So this would now mean that E over VA B would now be equal to L over L0. And this time we would now have this is equals to plus, what is that? IR, and here over the, so this time now this VA, it is equal to, to this IR, and then this is equal to L over what? So we have, this is L over, so L is 0, and then we end up determining this is going to be, so this will be equal to what? So here we have, so we close multiplication, and then what do we find? We are going now to find L, which is equal to, this is L, this is L over L0 equals to, this we close multiply, but this one is simplified because it is common. Here we have I, this is R plus R over R, and this is, this is over R, here equals to L over L0. And what is, so here there is, so what do we find? We find that this is over I, and then simplification, we remain with, so what do we see there? So this is going to be, it is going to be equals to, that is, here we have R plus, here that is over R. Then this gives the L. So here we can cross multiplication, and then we find, what we want, if we make the R the subject here, so what do we find? If we make this R the subject, what do we find now? What do we find? If we make that R as the subject, do you see what we are going to find? So try now to observe that. So when we put that when we try now to make it in detail, so it is going to be L over L0 times, this is R, then times R. Then here we have minus R, so that's right. And then here it is going now to remain only R, okay? So then this time now R will be equal to, try now to see that we have L over L0, then minus 1, okay? So then this is going to be, here we have this is R, okay? So this is what we have. So this time, it is when now we now have this L0. So you see that L0 is very big. It's a value that we have. L0, it is the big one. So this is the L0 from here up to there. So then from here up to that is L, which is small. And if we subtract this one, what is going now to happen? This one will be small, right? And if it becomes small, so when we subtract, so we remain with the negative. So with the negative there. So then the students, what I have considered is going now to be what we have in detail or into the explanations in general. So we have this explanation. As what I've told you, from here up to there, it is where we have called the what? L1. So this is, for us, we are calling it here we are calling it as the L0. Do you understand that? So this time here, we have, this is L1, and this is L only. So, and everywhere that you have that, there is going out to be L1. Do you understand that? But never mind. If we have used this, it makes you now even to understand this in detail or more. Do you get that? So let's keep this one here. But again, if you have followed this diagram, it is okay. So you can now get to understand it more. Even the demonstration, the proof that we have used it, you can now get to understand, right? So you have this, and you have this one also, but they're all just leading to the same answer. So let's have a quick example. This is an activity. So can we have it? So we are expecting now here to find the answer, right? The figure below shows a 2.0 volt potentiometer used for the determination of internal resistance of 1.5 volt cell. The balance point of the cell in open circuit, remember, in open circuit, here we have a 73.3 centimeters. When resistor of 9.5 ohm is used in a circuit of the cell, the balance point shifts to this centimeters length of the potentiometer. Then determine the internal resistance of the cell. What can we do? So we find now the internal. So you see, it is a similar diagram as what we have used it to demonstrate. It is the same. Here we have that. But try now to do this. Substitute this into, make this as 9.5, right? And they put here that 1.5 volts. And then here you have the driving voltage is 2 volts, okay? So then you put them there, and then you substitute. So here we given. So what is given there? So what we have is E 1.5, This is E equals to 1.5, right? And what we now have next is we have, we have L. This is L. L is 0 equals to 76.3 centimeters. Then L here equals to 64.8 centimeters, right? And what is there again? It is this R. This R equals to 9.5 ohm. And then we have the formula there. We substitute. So we use that formula. Here we have 76.3 over 64.8. So this is in centimeters, and they are closing each other, and these centimeters. And we have minus 1, and times this 9.5. This is ohm. And what is the answer? So can you just do it quickly? So I hope that you have finished to calculate that. So let's do it together. So here we have, this is going to be 76.3 over divided by 64.8. And then we have minus 1, right? So that is minus 1. And then we close the brackets. So we find, and then we multiply that one by 9.5. This is 9.5. Then we find, what did you find? What did you find there? So I hope that you've determined that is going to be 1.6. So 9 ohm. So let's use this value. So we are using the two decimal places there. So this is going to be the answer. I hope that you've found the term. So it is there. But now let's hurry up. Let's move on to the next point here. It is measurement of current by potentiometer. So this is simple now. Very simple. Because it is a diagram that we are going now to consider. As you see, we have from this diagram here. So we have the circuit here. It is downward, right? Then, so we apply the same thing. And then we say, okay, so this current here, we're moving around this. So you know, we apply this Kirchhoff's laws. And then again, what is next? We have everything here as what we have started into this explanation over here. And then we find, so the expression, of course. So let's do that together now. So here we have, as what you observe, so there we have even said that let's say that is VAB over E equals to L0 over L, right? That is over L. So then after, here we have E, which is equal to, that is E equals to, So this is VA, VB equals to L0 over L times E. So times this electromotive force here. So that we can now say to be this one, this time. So then, if we are saying, let's make it now just clear. So there we have E0, okay, corresponding to L0. So this is L0. Then another one, it is only this one for VAD. So this is what we consider here. So we match with the diagram that we have there. So then this VAD will be equal to, so here it is VAD equals to, we close, and then here over L0. This is what we have. So, but now, what is next here? So what is next is this VAD will now be equal to the current. That is the current. That is the current that is moving, that is closing the resistance that we have. That current is Hey, do you see this? It is I1. So I1 here equal just times the resistance. Do you see that one? So then we can find that. So here we can find the current equals VAD over the resistance. That's what we have. Then let's make a substitution of this expression here. So then here we find VAD, that is the current as the subject. Current I1 equals VAD correspond to all of this one. This is L over L0, then times E, then over the resistance. So students, what we have as the expression, so as the expression of how to determine the current. So the current by a potentiometer, it is now determined by using or by having this, only this expression, right? So it means that, suppose that we were given that, we're given this, you see what is there? We're given E equals to 1.3. That is the volts, okay? So then we also have the L at the point, at the balance of this resistance, that L equals to, let's use even the one that we had previously, 63.8 centimeters. Then that L0 equals to 76.2 centimeters. Then what is there as a resistance, if we use that 9.5 ohm, then we can find the current. The current here will be equal to, let's substitute immediately. What do we find? We find that one. We find this is 63.8 over 76.2, then times, we are using that one, right? So then times that is 1.3 over the resistance is 9.5. The answer is going to be in 2 ampere. So this one is going to be, so what is going to be the answer there? So can you do that? And then you finish. So what will be the answer here? So the answer. So I have the 63.8. That is over, that is 7. No. Here it is. And this is still times 1.3. And then divided by 76. I think that you are using your calculator, right? So then over 9.5. So this is over this one, all the times. So this, the answer in 2 ampere. So if we do that, and then we calculate it to be 0.11, so that is 11 ohm. So this is the answer. Now, students, after we explain what we have there, so this is what I have, just what we have, what we were explaining. Then I have a homework. The homework that I have for you, we have 2 questions. We have this one, and do these questions, but add on more other questions you found on the same page, right? Thank you, and I think that you have used this ampere. Good. So then we will meet again into the other next lesson. Thank you for having me today. Bye-bye.